Okay, we're back. This is check-in number 4 for AP Physics C, E&M. This one is about DC circuits. So we're going to take a look at some of the questions that I asked. If you haven't seen them yet, go ahead and pause the video and try the problem. Hopefully you can read this. This is a circuit that has a 120 volt power supply, and then you have a bunch of resistors, 20 ohm, then there's a 50 ohm, and then on the top part 40 and 20, and on the bottom 70 and 20. And they ask several questions. So I'm going to probably give you the details and then give you the final answers, but it's one of those things that hopefully you follow along with what is being asked in these problems, and we go from there. So the first question is, what is the equivalent, REQ, equivalent resistance, or sometimes known as the total resistance? You probably know it as a total, but equivalent means if you took the same current for just one resistor instead of having all 6 of these, what would that equivalent resistor be? So now we call it the 20 or the total resistance, so we're going to try to find that. I hope it's safe to say that the bottom here is in series, so that if you add those two together you get 90 ohms. On the top, those are also in series, that's 60 ohms. If you take 1 over 60 plus 1 over 90, I believe that gives you 36 as a total. And then you just add those two together with the 50 and the 20, and that gives you a total resistance for that of 106. Hopefully you got that same answer. For part B, it says, what is the voltage across the 50 ohm resistor? Well, I think once you find the total resistance, it would make sense to find the total current. So I would just take the total voltage of 120 volts and divide by the total resistance, and that's 106 ohms. And that gives you what the current in the circuit is, and I got 1.13 amps. That's a rounded value. You can use your unrounded values in some of these calculations. You might get something a little closer to what I read off. But the voltage in the 50 ohm resistor, then it's going to see that total current, and then you just multiply by that resistance. So 1.13 amps, V equals IR, times 50 ohms, just using Ohm's law, gets me an answer of 56.6 volts. Hopefully that's the answer you got for the 50 ohm resistor, 56.6. So we'll put that off to the side because that circuit still matters, but they ask in the next part, what is the current through the 40 ohm resistor? So on the top part of that circuit, what's the current? How are we going to go about finding that? Well, it's important that we know what the current is on the top, but I think it starts by knowing that the resistance, that should say top, or excuse me, let's back up a step. The resistance of, say, the box there is 36 ohms. And so I think we might want to know what is the voltage at different spots. What is the voltage for the whole box? I think the voltage for the whole box would then be equal to the total current times that resistance. So if you took what I got in the last problem, 1.13 amps of total current times 36 ohms, that gives you what the voltage is there, and that turns out to be 40.7 or 40.8 volts. Okay. If you want to know the current on the top part of that branch, because you know it comes in and say that's a junction right there, part goes to the top, part goes to the bottom. The part on the top would just be the voltage on the top divided by the resistance of the top. Well, the voltage on the top is the same as the voltage on the bottom because they're in parallel, 40.8 volts, and the top part of that is a 40 and a 20, so I believe that's 60 ohms between those, and that gives you 0.68 amps, and that would be the current in the top part which of course would be the current through either one of those. So that's the answer to that question, 0.68 amps. The last step would be find the power dissipated in the 70 ohm resistor. Again, the 70 is now on the bottom. I think if you want to know the current in the bottom, would it not be true that that would be the current in the top part subtracted from that, sorry for scratching that out, total current minus the current in the top. So we said that the total current was 1.13 amps, and we're going to subtract from that 0.68 amps. And if you do, that's going to give you 0.45 amps as the current on the bottom. And the power, there's three different ways you could find the power, and I'll just write them down so that we're aware. Power is IV, it's V squared over R, or in this case what I'm going to use is I squared times R. So the power in the 70, dissipated in the 70 ohm resistor, should be the current squared, 0.45 amps squared, times that 70 ohms of resistance. And if you do that, I ended up with 14.4 watts of power. So that is the answer to that question. Hope that makes sense. Let's go ahead and go on to the next question. If you have this circuit, you have a power supply connected to two that are in parallel, a third resistor in series with that, two more in parallel, and a sixth resistor in series. There's a couple questions that are being asked here. Number one, for that circuit, if you want the voltage measured across R1, what is the voltage? It asks what kind of device would you use and where would you place it? Just a experimental type question. Well, the device used to measure voltage is what we call a voltmeter. And where would you place that voltmeter for that? I think I'd put that right here, put my voltmeter across that, and that's where I would measure the voltage. Okay? Hopefully that makes sense. They do the same question, but they ask what would be the device you would use and where would you place it if you wanted to find the current through R4. The device that you're going to use, we're going to call an ammeter. That measures current. Whereas that one, the voltmeter measures voltage, the ammeter measures current. Okay? Probably aware of that, but it's good to at least state it. Now, where are you going to place that ammeter? Well, it's going to go through here. It's got to go through that resistor. So you can put it on either side, but you just have to break apart and put the ammeter right there next to that resistor. And that's how you measure the current. So that would be the quick answer to those two questions. I think from all the labs that we've done, that should make sense. And you should have been able to answer that question pretty well. The last one's more of a conceptual question. And how are you going to handle if you have three identical light bulbs? A light bulb is basically a resistor. We're labeling these light bulbs as A, B, and C. It asks, compare the intensity of light when the power supply is connected. So between those two, they're both A and the combination of B and C, which are in series, have the same voltage because they're connected directly in parallel to that. But I think it would make sense if you go back to the equations we just had for the last problem. You're interested in the power, which would be the current times the voltage, voltage squared over the resistance, and the current squared times the resistance. Well, the current, well, the voltage is the same for both branches, but you're going to divide by a greater total resistance. So you're going to have less power for the two in resistor. You have a greater power and therefore a greater intensity for bulb A. You can look at it many different ways. The intensity should be greater because you have a less total resistance. and so the current's going to be up. So the intensity of A is the highest, and then B and C are going to have the same intensity. I hope that makes sense. Hope I explained that okay. How about if you unscrew light bulb A, what would happen to the intensity of B and C? And the answer is nothing happens to that, because they're effectively still hooked up in parallel with B and C. Therefore, the intensity, that's still going to draw the same amount of current through that part of the circuit, therefore the intensity should stay the same. Okay? So the answer to that is I don't think anything's going to happen. The intensity for part A, the intensity of light bulb A is greater than that of B and C. And then the last one says, how about if you unscrewed light bulb B, what would happen to bulbs A and C in terms of intensity? Well, since B and C are in series, I think if you take out B, that would also take out that part of the circuit over there. So C is no longer lit. So A will stay the same intensity, but C would have to go out. So it really, again, because of the fact that they're in parallel, that doesn't take away anything from A, but since there is no current, there should be no lighting or no intensity. Okay, hope that makes sense. I think those are the answers to those three questions. We'll see you next time. Stay safe. Bye.